Hey, it's Mr. Osborne. Made a video for you guys on factoring using what we call GCF. Now, on your notebook, go to the next open page, and I want you to put this title at the top, Factoring Using GCF. Okay, let's take a moment to do that. Pause the video if you need. Okay, now, what is factoring? Okay, essentially what factoring is breaking down a number. We're going to break a number down. So, for instance, you guys may have remembered this at some point. If I take the number 18 and I want to break it down, well, I say, what do I multiply to get 18? Okay, well, 6 times 3 gives us 18. But then can I break down one of those numbers? Well, if I break down 6, that's 3 times 2. And can I go any further? No. So, essentially, 3 times 2 times 3 is equal to 18. And each of those numbers that you see there are factors of 18. Okay? And that's what we're going to do with polynomials. We're going to do that same idea. We're going to break down the polynomial. Because when we do that, later on, that gives us useful information to figure out what the behavior of a polynomial, especially when we talk about graphing. Or if we're trying to figure out a situation and we want to know when does it start, when does it end, factoring out a polynomial really helps us figure out that information. So, starting with number 1, go ahead and write this at the top. This is your first example. What you're going to do is first look at the numbers. So 2 and 10. We'll deal with the variables next. Okay, first we'll look at the numbers. Okay, so now with those numbers, let me get a new color here. We want to figure out what is the greatest common factor between 2 and 10. And that's what GCF stands for. GCF is greatest common factor. Okay? So another way to say that is, what is the biggest number I can divide into both 2 and 10? What is the biggest number you can divide? Can I divide 5 into 10 and 2? No, I can't, because 2 is too small. So I'm going to start with the small number 2. I know I can divide 2 into I know I can divide 2 into 2 itself. I know I can divide 2 into 10. So that is a common factor between the two. So erase that. So then on the next step, I'm going to write that number, 2. Okay? But I'm not done yet. That's just the common factor between those two numbers. But now I want to know, what is the common factor between the variables? Okay? Well, I have to ask myself, what is the same between b to the 6 and b to the 5? If Eduardo has 3 sisters, and I have 4 sisters, don't write this down, say 3 sisters, and I have 4 sisters, well, that means that we both have 3 sisters, at least. So what that means is we have 3 sisters in common. So that is how we factor the variables. How many b's does b to the 6th and b to the 5 have in common? Well, if Eduardo had 3 sisters and I have 4 sisters, and together we have 3 sisters in common, we both have at least 3, well then here we both have at least 5 b's. So b to the 5 is the common factor between those two variables. And we're still not done. Now, in order for this expression that I'm going to write to be equal to the first one, I'm going to have to multiply this GCF. So remember, this is now our GCF, times two numbers in here so that it will equal this. Okay? And I'll show you how to do that. So here, I have to find a number that when I multiply 2, I will get the original 2. So 2 times what equals 2? Well, just 1. And then the same thing for the other number. 2 times what equals 10? Well, that's 5. Okay? And then I do the same thing with the b's. B to the 5th times how many b's equals b to the 6th? Well, remember when we multiply the variables, we add the exponents, so we need one more, b to the 1. And then the same thing here, b to the 5th times what equals b to the 5th? Well, that's the same thing, right? So it's just 1. Okay, and now there's a plus in the middle, so I'm going to put plus. So now let's simplify that, because I've got all these 1's everywhere that I don't need. So that's going to be 2 times b to the 5th times, I don't need this one, and I don't need this one, so it's just b, plus 5 times 1, which is just 5. Okay? So not all that sounded pretty complicated, maybe, because I explained a lot. Okay, but as we go through these problems, I think you'll find it not so hard. Okay, so let's go down to number 2. Okay, so again, we're going to start with the numbers, 24, 15, and 3. And we want to find a number that will divide into both of those. Okay, so we have to think to ourselves, what number divides into 24, 15, and 3? Well, you always want to start with the smallest number, because you can't go any bigger than the smallest number. So, 3. Let's try 3. 3 goes into 3, 3 goes into 15, and 3 goes into 24. So there's my common factor for the numbers. Now I'm going to look at the letters. Now again, how many k's are in common with each one? Well, this has 4, this has 2, and this has 1. So if we only have 1 k for this last term, well, they only have 1 k in common. And just like the first one, this was the smallest variable, 5b to the 5th, and so we can't go any higher than 5. So here we can't go any higher than just k itself. Okay? Now, we have to complete the expression. 3 times what equals 24? That's 8. Okay, and we'll do the k's at the same time. K times how many k's gives us 4 k's? K to the 3. And then bring down the sign. 3 times what gives us 15? 5. K times how many k's gives us 2 k's? Well, just one more k. Bring down the sign. Then 3 times what equals 3? Well, it's just 1. And then k times what gives us k? Well, that's just 1, because we don't need any more k's. Okay, so let's simplify it. Let's get rid of some of those 1's. So now we have 3k times 8k to the 3rd plus 5k plus 1. 1 times 1. Now let's clean this up a little bit. Our GCF. And remember, that's our GCF there. Okay, and that's our answer. We've broken it down as much as we could. Okay, we factored out our GCF. Okay. Now again, let's try this again. Start with the numbers. And don't worry about the signs. Don't worry about the negatives. We're just going to bring those down in the next step. So now when you guys look at these numbers, it might not be so obvious to figure out what number divides into all of them. So what I do is I like to try to make a list of different numbers that I want to try. So 2, 3, 4, 5 I know is not going to work, and maybe 6. And so if you're kind of stuck and you're not really sure, go with the easiest one and just start there. If you don't know what the biggest one is that divides into all of these, just start with the one that you know. I know 2 works, because you can actually make up for it on the next step. Okay, so now let's divide 2 into every number, okay? And then let's go to the variables. R to the 6th, R to the 4th, R to the 3rd, R squared. Okay, and remember, R6, R4, R3, R2, they all have at least 2 in common. Okay, and usually the lowest exponent is going to tell you how many r's are in common. Okay, so now 2 times what gives us 54? Well, you just punch it in a calculator. What divide 2 into 54? And that gives us 27. Okay, r to the second, if I have 2 r's, how many r's do I have to multiply to get 6? Well, 4 of them. Bring down the sign. 2 times what equals 18? 9. And again, you can just divide. 18 divide 2 gives us 9. Okay, and then r to this r squared times how many r's gives us 4 r's? 2. Bring down the sign. Let me do this a different way. 60 divided by 2, 30. Okay, 12 sorry, don't forget the r's. I have 2 r's here, 3 here, so I need 1 more. Plus 12 divided by 2, 6. Okay, and then if I have 2 r's here, 2 r's here, I don't need any more here. Okay, and I wrote a 1 before you, but you don't need to. All right, so now let's look at our numbers. Let's see if we found the greatest common factor. 27, 9, 30, and 6. Well, if I'm looking at those numbers, I'm pretty sure there's a number that divides into that. And right away, I can see that 3 goes into both of those numbers, all those numbers. So let's just do GCF again, because remember, you want to break it down as much as possible. Okay, so I'm looking at 27, 9, and 30, and 6, and I know for sure 3 can be divided. So I'm going to add 3 to the factors I took out, and when you do that, you multiply it times the 2 out here. So another way to do this, because remember I told you this number times this number gives you this number, is just divide it. So I'm going to divide 3 into all of my numbers here. Divide 3 all the way across. And now, in the next step, and I'll do that on the next problem, maybe you guys will like that better. Okay, so now I need to multiply here, 3 times the 2, because this is going to be my new GCF. And let's write out my r squared. And now, all I'm doing is dividing the 3 out into all of those. So 27 divided 3 is 9, and it's still r to the 4th. And then 9 divided by 3 is 3, r squared. And then 30 divided by 3 is 10, r. And then 6 divided by 3 is 2. And then there is my polynomial divided, factored out, or with the GCF factored out. Okay? All right, so number 4. So again, look at each number, and I'm going to do this a slightly different way that you guys might like a little better. First the numbers, and I say, okay, what numbers divide into all of those? Okay, well, 2 is the most obvious number. Okay, and then I look at the x's. How many x's are in common? And I go to the lowest number of x's, so only 1 x. Okay, next thing. Now, what I'm going to do, like I did in the last problem, is divide 2 all the way across. 6 divided by 2 is 3. Okay, if I have 1x here, I need how many to get 4? 3 x's. Bring down the sign. 4 divided by 2 is 2. Remember, this 2 it came from the number that I factored out. Okay, x times how many x's gives us x squared? Well, I just need 1 more x. Bring down the sign. 6 divided by 2 is 3. And then x times what gives us x? Well, we don't need to multiply any more x's because it's just 1x. And that's it. Okay, last problem. Okay, again. Numbers here, numbers here, numbers here. What number divides into all of those? Well, I see that this ends in a 5, this ends in a 0, and this ends in a 5. So a 5 obviously works. So I'm just going to use one color this time. So we'll do 5 here. Okay, and then we'll go to the variables. And remember, you look at the lowest number, or lowest exponent. That's this r to the 2. That's how many are in common. And I took out 5, so I'll divide 5 all the way across. Okay, so 45 divided by 5 is 9. I have 2 r's here. How many r's do I need to make 5? 3. 50 divided by 5 is 10. I have 2 r's here. How many do I need to make 3? Well, I need 1 more. Okay. Bring down the sign. 35 divided by 5 is 7. I have 2 here, so I don't need any more here. And there's my answer. Okay, that's it.